So I just posted the work that we did a couple days ago, so you can grab that. And I was thinking that maybe we can work on expanding the scene potentially, but I think what I'm going to do today is going to be a separate scene, and maybe we can incorporate it into this scene. But you can grab that from the Git repo. So if you know Git, what you're going to want to do is clone this into an existing Unity project. So this is not a Unity project. It's meant to be a subfolder that lives inside your assets folder inside of a Unity project. So I did that so you can bring this into any Unity project that has your own stuff in it, and there's less overhead and stuff like that. If you don't know Git, or if you don't want to deal with Git, you can click on code and you can download the zip file, and then you can drag it into the assets folder of your Unity project. So in this case, this folder lives under my assets, and I have some other stuff outside of that. So if you're doing work with any of this stuff, I would say maybe if you want to use Git and you want to do work using some of this stuff, maybe duplicate it and move it outside of this directory. So in case anything gets updated, it won't overwrite anything that you make. So today, I think we're going to make something in a totally different scene. We're going to be talking about very different things today. In the last workshop, we went over how to take 2D images and use Unity's sprite renderer to create spaces and objects. So this environment is actually a room here at SETI, and we built it by just taking a photograph, a straight-on photograph, and then we chopped it up into pieces and turned these into sprites. And we were able to make it a fully 3D room that you can walk around in VR. And it's actually, even though it's very simple and it's just based on one photograph, no fancy photogrammetry techniques, just very take a picture of a texture, map it on a plane. It's pretty convincing. It works pretty well. It's great for prototyping, even good in some cases for final projects. So today we're going to get a little bit more technical, and we're going to get into shaders. So I guess maybe before I hop into that, there are people from the last workshop here today. So I don't know if there are any burning questions from the work we did in the last workshop that might feed into what we're doing today. Everything is pretty straightforward. Everybody's good with everything we did. Okay, cool. So we'll move on to the next stuff. So a shader is a program that runs on the graphics processing unit on a computer, and any object that you see on your screen in a game, in VR, whatever, everything runs through a shader. And shaders primarily do two things. They position the vertices of your object. So I'll show you again what vertices are. So if I go to wireframe mode, these are the vertices that make up the geometry that's used to actually render these objects. So a shader is used to position all of these vertices so they're in the right place on the screen. So that's a vertex shader. And then a fragment shader is used to render the colors of all of the pixels on your screen. And the reason it's called a fragment shader as opposed to a pixel shader is because for the most part, you're rendering more fragments than pixels. You might have 4 or 8, I'm not actually even sure how many more, but it's like by rendering more fragments than pixels, you get anti-aliasing. And anti-aliasing is about smoothing edges of things. So, if you see an image that has no anti-aliasing, there's a lot of staircases. In order to create quality anti-aliasing, you have to render more pixels, and that's where fragments come in. So a fragment is smaller than a pixel, but it's the same idea. The idea is the output is into a 2D space. So every surface that has these vertices gets sampled in screen space, and math is done to calculate lighting and to sample textures and to do all kinds of stuff to actually represent it on the screen for you. So we're going to dig into that a little bit and just try out some stuff with shaders. And I have a few things that I'm going to show you right off the bat. And then after I show you some of that stuff, probably for the afternoon session, I'll take some requests and I can make some things that you're interested in making and show you how to do stuff. So as I'm showing you things, maybe think about things that you're going to want to make and we can try to do that. So I'm just going to make a new scene. Oh, and something to note about the way I'm going to show you shaders is that it does require the use of Unity's shader graph. And in order to get that to work, you need to be on one of the scriptable render pipelines that Unity uses. So maybe I'll go over really quick how to install one of those. If you go to Window Package Manager, and then if you just start typing in univ, let's say, that should get us there. So universal RP, so universal render pipeline is what I'm using. And instead of remove, you should have an install button. So if you click on install, it'll go through a process of installing that. And then after that's installed, you can go into, how many people want to do this? Like, people want to try to follow along with this? Should I pause for a second while you get that installed? Sorry. Okay, so anybody that needs individual help, we can do that. I'm going to go to the next step for everybody that's ready. Once you have that installed, and maybe just like pay attention for a second, maybe write it down, and then you can review once your installation has happened. You're going to want to make one of these universal render pipeline assets. And in order to do that, I'm just going to right click in my project window and I'm going to go to create, and then under rendering, under universal render pipeline, there is a pipeline asset. So this is the very first one. So you're just going to want to create one of those, and we don't really have to do anything with it right now. We just need to have one in the scene. Okay, so different Unity versions for people who are streaming might have different ways to do this. So look up in the Google Docs. You just need to, search in Google for Unity Docs. You just need to look up how to switch to the universal render pipeline. There's a series of steps. The last step is to go to your player settings. So I usually get there by clicking on build settings, and then under player settings, we need to go into graphics, and then under scriptable render pipeline settings, we just need to choose the pipeline asset that's in the scene. If you want to do this the easy way and not convert a project, you can actually just create a brand new project from scratch. So if I just say new project, I can choose a template, and I can choose URP template. So that will just have all of this set up for you from scratch. So maybe that would have been the way to do this. But either way, if you have a project that you want to be working with, it is possible to change that. Okay, so while everybody's getting set up with that, I'm going to hop in and show some basic things. Okay, so for right now, I would say don't worry about following along because we'll come back there. But now you have the stuff. So if you'd like to pop in and do some of the stuff, it's okay. But I won't be waiting for people to catch up. So first, I'm just going to show you some basics about what shaders do and how shaders do it. So I'm going to make a new URP unlit shader graph. In order to, so this is a shader program. In order to actually use the shader program, we have to create an instance of it. So we need a material that refers to this program. So an easy way to do that is if I right click on this and I say create material, it will automatically make a material that uses this as its program. So with any material, I can go up and I can change the shader, that's the program that's running the shader, to anything else. So this is just how Unity works. Like as with game objects, you can have different kinds of components. With materials, you can change the shader program. Generally, you don't do that. Generally, you pick the shader program that you're working with, and that's where it stays. So by default, I can show you what a default material looks like. I'm going to just make a sphere, and I am going to drag this material onto the sphere. And by default, a shader graph creates a flat gray material. Beautiful. So this is our starting point. If I hop into, if I just double click on the shader graph, I have a few windows. So in the center here, this is the node graph, and this is where all the work happens. Over here, these are some properties of the shader, so we can change some attributes of the shader at a high level. And over here, this is where we add variables that we can access from the outside. So if we want to add textures, if we want to add float values to change properties of the shader from Unity, this is where we would add them. So in here, this is our Vertex program, and this is our Fragment program. So this part is responsible for the colors of the surface. This is where lighting generally happens. If we're going to display a texture, that would get output in the Fragment shader. And then this is the Vertex part, and this is responsible for setting the position of all of the vertices, placing the object in space. There's actually a few items here: position, normal, and tangent. So the position is literally just where the vertices are in space. So if I have the sphere object, if we actually looked under the hood at a piece of 3D geometry, just do that. This piece of 3D geometry is a file that has a big list of vertex positions, and those vertex positions are based on their relationship to 0. So if we look at this vertex right here, that's directly to the right of the center, that vertex, if we looked at the file, it would, like, if this is an OBJ file, we'd see a list of vertices that would be represented with the letter V and then 3 numbers. And this particular vertex would be 1, 0, 0, because this is in the x-axis, so it's represented as X, Y, Z. And this particular vertex right here is out in 1, and it's 0 in Y, and it's 0 in Z. So over here, this vertex that's right on top would be 0, 1, 0. And then all these other vertices, between them are going to have combinations of negative numbers and positive numbers, but all those vertices come, like, as a model, are in relationship to 0. So what happens under the hood with vertex shaders is that there are a series of multiplications that happen with matrices, which you don't have to know anything about. And the idea is that we have this transform that takes this object, and that transform matrix gets passed into a shader, and the shader multiplies that matrix, all the vertices of this object, by that matrix, and then it also multiplies it by the matrix of the camera. And the camera matrix is responsible for adding perspective to the scene. So there's a series of operations that happen to take our object that really just exists in a space where it's like it can't really be viewed until it gets transformed in that way. So these are things you don't have to know too much about. It's helpful to know that this is more or less what's happening. There are a series of transformations that are happening to these vertices. They're happening in the shader, and you can make use of that understanding as we get into some of these shaders. But you don't have to know how it's done. By default, Unity plugs this stuff in for you. So there's stuff going on under the hood. We can't access it. The way it's set up, you have to have some stuff going in there, or Unity doesn't know what to do. So we can't delete these, but we can replace them, which we'll look into soon. So down here, kind of the same deal. Unity wants there to be some kind of color, at least, going in there. But we can connect other things there, and we'll start playing with that. So I think the first thing I want to show you, so Shaders make use of attributes that are in the geometry that you give it. And there's some like the main attributes that we're going to work with are the position of the vertices. And then we're also going to be working with the UV coordinates of an object. So UV coordinates are, it's like a version of the 3D model that has been unwrapped into two-dimensional space. So if you think about a Mercator projection map, if you were to look up Earth texture map, what you would see is an image where Antarctica is a strip of white on the bottom, and the North Pole is a strip of white on the top, and everything's like stretched out in weird ways. And the idea is that that is basically a sphere that has been unwrapped. So typically when you look at the UV coordinates of a sphere, it's actually just a square, and we can take that texture and it gets mapped onto the 3D object. Does anyone have any questions about that? I'm going to show you some stuff, so it will hopefully make more sense. But if I go in here, there's a whole bunch of nodes. If I right click, I can click on create node, and I can search for stuff. There's a lot of options here. There's a lot of options under UV. But the one that I'm interested in is just the one called UV. So yeah, under geometry, UV. So why is it called UV? Because those letters were available. It's arbitrary. U and V don't stand for anything. So what we're looking at here is, you'll see this a lot when you're looking at UVs. The idea is red is U and green is V, and they just add on top of each other. So that means in the lower left corner, the U and the V are both 0. In the upper right corner, the U and the V are both 1. And then in the middle, there's sort of variations. It's like, between 0 and 1 is typically where UV coordinates live. So if I just take this and stick it into my base out color and hit save, I want to reload it and lose the changes made in the graph. Save. Okay. Okay, so I'm caveating. I'm going to caveat today's lesson. I was going to do all of this in code, and I was convinced to switch to doing this in the shader graph because it's much more visual. I'm less of an expert with the shader graph, so if I stumble, I apologize in advance. I spent many years working with a shader graph in Maya. Shader graphs have been around for a long time, and lots of different pieces of software have their own versions of shader graphs. I think Unity has lots of different kinds of shader graphs, actually. And the idea is like the shader graph gets compiled into code, which you could actually go in and manually change to. So depending on the appetite of everybody here today, I can also show you how to do all of this directly in shader code, which is what I normally do. So this is what UVs look like on a sphere. So the V coordinate, which is y, u, v, x, y. The V coordinate goes from the bottom to the top. So it gets more green as it goes up. And then the U coordinate maps to the X, and that is red. So it gets more red as it goes from here to here, and then it loops back around. So one thing about going off the edges, if you go from 0 to 1 and you keep going to 2 or to 3 or to 4, it tiles, basically. So if we have a map that is the same on the left edge as the right edge, we can like animate it, continuously, and it'll just loop. Or we can set the number of repeats, so we can set our UVs up so that they repeat, and then whatever texture is mapped to them will tile to. So if I want to, so this is how we can do various things with UVs, but the main thing that you would use UVs for is to map a texture. So if I want to bring in a texture, I'm going to go up to this section over here, click the plus, and bring in a texture 2D. And Unity sort of, like there are a lot of things you can do easily in Unity, like sort of set the texture of a shader. And if it has a property called main text, Unity is gonna have an easier time doing certain built-in things. So I'm going to make this and call it main text. It actually doesn't matter what this is called right here. What really matters is what the reference is called. So when I click on this and the inspector comes up, just for my own organizational needs, I'd like to name the reference the same as the name. So the name is what's visible to you. The reference is what's happening under the hood. And if you want to programmatically access this shader, you would use this reference name. So I'm just going to copy that name from there to there. Not such a big deal right now. So don't worry about these things. Name things however you want, but maybe keep that in mind for later. Okay, so now I have created this. Do I have this open twice or something? Why does it keep asking me if I want to reload? Okay, so if I click on my sphere, I can see the material that's assigned to it here. I can also click directly on my material over here. And now I can give it a texture. So let's see. Okay, cool. So I have a texture. I've assigned it. Nothing's happening yet because I haven't actually brought that texture into a place where it's going to display. So in order to do that, and this is like a slightly annoying process. There's like a variety of nodes just to get to the point where we can see stuff. But once we get to that point, once you start to figure out how nodes work, it becomes very flexible, very fast. Does anybody have experience with node-based programming?
Max MSP and like Touch Designer's versions of that.
Okay, cool. Yeah, if you're familiar with anything, like Max MSP is used for audio, and Touch Design is similar to Unity in some ways, but it's all based on these kinds of node graphs. So a node graph is just a different kind of programming. It's a visual programming language, basically. So everything that you're seeing with these nodes can also be done directly with code. I'm going to drag this main text into the scene. So now we just have a little node. We can't see what the texture is here. We just know that it is a texture. And then what I would want to do is just drag that right into the base color of the fragment, but I can't do it because this texture doesn't know enough to be able to output directly. So I actually need to sample the texture using something. So I'm going to create a sampler, sample texture 2D. And then I'm going to plug in my main text into there. And something you'll notice is that the UVs have a default node already connected to it. So Unity will do that. If there's a thing that it thinks you're going to want, it'll just put it there by default, and then it's up to you to replace it. So by default, this will just use the built-in UVs of the object. So for right now, that would be fine, but I'm going to want to do some stuff with the UVs. So what I'm going to do is take this UV node that I made and just plug that in, because I'm going to want to do some stuff with that later. So now I have my UV and my texture going into my sampler node. And then the sampler has a variety of outs. So right here, this says RGBA4. So what that means is that this is a 4D vector. So it's going to give us XYZW or RGBA. If it's a color, RGBA. If it's a direction, XYZW, or something arbitrary, XYZW. Or we can get individual channels. So the individual channels here, because this is outputting a color, are RGBA. And when you're coding shaders, RGBA or XYZW are often interchangeable, so you can refer to one or the other for the most part. So for this, the fragment shader wants a 3. If I take this 4 and put it into the 3, it'll know what to do. It'll just take the first 3 values, the R, the G, and the B. So now we have all this stuff plugged in. You guys know if there's some way to see the texture in the node graph?
If you click main text upper left, you can give it an overlay over on the right, you can give it sort of this preview texture, so you can see it here.
Okay, so this is just for, this is like a default texture, just so something shows up in the shader, but this can be overwritten in the Unity editor. But this will be helpful for us. So this is the texture. It is getting sampled using these UVs, and it gets laid out nicely like this. So in our original texture, it doesn't matter what the resolution is. The bottom of the image is 0, the top is 1, the left is 0, the right is 1, and it's just going to get mapped like into whatever shape it needs to based on these incoming UVs. Okay, I do have that open twice, that's why. All right, so now I have that flame wrapped all the way around the sphere, and I'm going to show you what UVs look like on different kinds of objects by default. So if I go up here and I make this a quad, this looks a bit more normal. So that's just the same thing. So you can see the UVs are different. The UVs are basically the same as the vertices with a quad. We can also do capsule. So capsule UVs like wrap around like that. A cube in Unity actually has multiple UV sets, so we can actually map things onto a cube in different ways. But by default, you can see that each face has its own set of UVs from 0 to 1, so it duplicates the image on each face. Cylinders have caps that have their own UVs. So the image is repeated on the top and bottom, and it looks like the UVs of a cylinder are repeated twice. So what I want to work with is this one, because I want to make a nice animated flame. So I'm not going to worry about these other 3D objects, and I'm just going to focus on this quad. So for our purposes, we actually, because this is unlit, we don't actually need to make use of normals or tangents right now. So a normal is a property of an object that tells us what direction a vertex is facing. So if we have a sphere, the normals of every vertex are perpendicular to the surface. So the normals will face out. So if I have a sphere, the normal on top is up, and then the normal on the bottom is down, and the normal on the right is this way. So it's like just directions like that. And that's very useful for calculating lighting, which right now we're not going to worry about. Since we don't need to worry about lighting, I actually don't need to even output normals. Can I delete that? I think so. That was the tangents that I deleted. So tangents are similar, but instead of facing out from the surface, they actually face along the surface. So this would be the normal, and this would be the tangents. And tangents are especially useful for calculating bump maps. And we're not going to be getting anywhere close to that, so we also do not need tangents. So what's happening is the vertex shader is passing what it's doing into the fragment shader, and the fragment shader is rendering it to the screen. I'm just going to save that, and unless I'm wrong, it should look identical. Yeah. So since we're not using lighting, we're doing anything with the normals for now. Everything looks the same. So it's actually a pretty simple starting place. So what I would like to do next is clip the black parts out. So this image is actually a PNG file. So this PNG file I got from toppng.com, and it has an alpha channel, and I'm getting the alpha source from the input texture alpha, but because this shader is set to be opaque, it's not clipping it out right now. So to fix that, I'm going to just switch the surface from opaque to transparent. And all right, so Unity wants those attributes back, so I'm not going to worry about deleting them now. I'll leave them in there. It's fine. So we get one more thing when I switch there. I got an extra spot, which is alpha. So if I save that now, it still looks identical. And the reason it looks identical is because I have not plugged anything into the alpha channel yet. But from my sampler, I'm getting the RGB and alpha channel from my incoming texture. So I can take the alpha and plug it in there. And if I hit save, now Unity knows to clip out the black stuff. So it just so happens that the color of my background is black, but let me turn the background back on again. Skybox. Let's see. How do I switch back to skybox mode? Oh, there we go. Great. Okay, so now you can see that we now have transparency. So what we have here is basically very similar to a sprite, which is what we were doing all of our work in a couple days ago. One big difference with doing it this way versus using a sprite is that Unity's sprite renderer will actually create geometry that conforms more tightly to an image. And the big advantage there is that it's cropping out geometry that is transparent. It turns out that having transparent geometry, even though you can't see anything, Unity can see it, and it has to do extra math even if you don't see anything there. So having a full quad, even though it has fewer vertices, is actually a little bit more expensive than a sprite renderer, which has more vertices but chops out those transparent bits. So for our purposes, we don't need to worry about that. It's like a thing you don't need to worry about until you have lots of layers of transparent things. And at least for now, I'm worried about very few surfaces. So you don't need to worry about that stuff until you do. So with what I want to do, I want to make this flame sort of wriggle a little bit. I want it to blow in the wind and give it some liveliness. So if I was using a sprite renderer that was cropped very closely, then with my renderer, it would be sort of passing over the edges of that tight geometry. So for what I want to do, having it be a quad is important. Any questions right now? Anything confusing about this? I know like node graphs are like their own whole thing, but everybody good right now? Cool. So what I want to do is make it wave, and the way to make it wave is to do things with the UV coordinates. So I'm just going to show you quickly some stuff I can do with the UVs. I'm just going to go ahead and add a vector 4. Yeah, I'll make it a vector 4. All right, I'm just going to make some values that I can use to just do stuff to the UVs, just so you can see what happens when I change them. So if I bring this in, this is a vec4, and one thing I want to do is I'm just going to start by offsetting the UVs, so you can see what happens when I move it, what happens when it goes off one edge onto the other edge. So to do that, I'm actually going to create an add node. And let's see if it's going to like this. So I'm just adding these vectors directly. So it seemed like that was friendly. Sometimes you have to, there are things that you can only do with similar kinds of inputs. So sometimes you have to convert things or split things out. I'll show you how to do that in a bit. For right now, it seems perfectly happy to add these two together. So I'm going to take this new UV set and plug it into the UVs. So now instead of going straight from the UVs into the sampler, I'm adding it to this Vec4, which will be accessible in the editor. So if I save that and I go over here, I can change these, and now the flame is moving around. All right, so we can do something else, which is to multiply it. So what I want to do is I want to add by the XY, but I want to multiply by the ZW. So to do that, I actually need to split out my ZW from my Vec4. So I'm going to create a split. I plug in my Vec4, and then I have access to any individual channel that I want. So then I'm going to make a vector 2. So I'm going to take my ZW and make that an XY. And I'm going to plug that in here. I'm going to take these UVs, put them in there. And I think this is going to be unhappy, but let's see. Let's see if this works. So I would expect it to be black and invisible because I'm multiplying by 0. So if this works, yeah, okay. So if I set these back to 1, 0, 0, 1, 1, has us back at default. So it's not being offset, it's not being multiplied. If I multiply this by 3, I see 3 flames. If I multiply this by 3, I see 9 flames. So many questions about that, multiplying, adding to the UV coordinates to offset the texture. Does that concept basically make sense? Or is it completely mystifying? Raise your hand if you're completely mystified, and I can like pause a little bit. Okay. So maybe what would be helpful actually is if I show you what's happening to the UVs directly. So if I go in here and instead of looking at the sampler, I'm actually going to take the output of my adding and my multiplying, and we'll just look at those UVs directly. Okay, so back to 0, 0, 1, 1. All right, so as I move, I'm basically moving my UV coordinates, and these are what's being used to map the texture. And if I multiply, what's happening is that the values that are going above 1 are perceptually clamped in a way. It's like this screen cannot display values above 1. Some screens can. Some screens can get brighter than bright. This screen can't. So basically what we're seeing here is a value from 0 to 1 in U. And then from here to here, that's actually 2. And that's actually 3. And that's actually 4. Even though it just like looks like it's clamping and stopping, it's actually going up in value. So because our texture is set to repeat, the wrap mode is set to repeat instead of clamp, when we actually map a texture to this, under the hood, Unity knows that from 0 to 1, it's going to map the texture the same way as if it's 1 to 2, or 2 to 3, or 3 to 4. So I'm just going to see if I can show you that. Let's see if this works. So there's a tool called Frac, which gives you a fractional amount. I'm not sure if this is just going to work easily. Okay, so basically Frac says like once it goes back above 1, bring it back down to 1. So instead of going up and clamping, we're actually seeing what those repeats look like. So this is more like what Unity is doing under the hood in terms of mapping the image to these coordinates. So I can multiply, offset, stuff like that. So does that help a bit with like visualizing what's happening with the texture as I offset and multiply? Okay, cool. So plugging that stuff in. So knowing that, we can actually do a lot of cool stuff just with doing things with the UV coordinates, because we don't have to have it be a square. We can have it be a rectangle, but we can also deform the UVs with different kinds of functions. So if I go, so we got the textures back. I'm just going to set these back to 0, 0, 1, 1. Did the idea of splitting up that vec4 make sense also? I went through that kind of quickly, but the idea was the UVs say that they have 4. It says it's a 4, like they come in as a vec4, but really the only parts of this that we're interested in are the x and the y. So it adds fine, but it's really, but because it's only the first 2 coordinates that matter, when we do this add, it's perfectly fine taking those first 2. So it's taking the first 2 of the UV and it's taking the first 2 of my vec4. But then in order to do a multiply, I wanted to use the second 2, the z and the w instead of the x and the y. So to do that, I used a split node. I took the second 2, made a new vector 2, and remapped them. So this is something, it's like, it is helpful to look at a little bit of stuff with vectors. Basically shaders, like everything that a shader does is vector math. So if you want to get into this stuff, it is handy to understand how vector math works. And it's actually pretty simple, and it's actually pretty easy to visualize once you get through the basics. I definitely had to do a refresher when I was getting back into doing shader stuff like this. I would highly recommend Nature of Code, Daniel Schiffman, vectors. Let's see if this will just pop up. Yeah, so this is even chapter 1 of Daniel Schiffman's Nature of Code. Is all about vectors and vector math. And this is incredibly useful if you want to be able to kind of visualize and understand this stuff. It's really handy to have an intuitive understanding of what vectors are doing when you do things like add them and multiplying them. Unfortunately, once you refresh yourself, it's not too hard, and that's very important with shaders. Okay, so we got that stuff going on. So what I want to do is I want to deform my UVs with a wave so that I can give a wave to this flame. So the easiest way to make a wave is with a sine wave. And there is a node built in called sine. So sine needs an input. The sine of 0 is 0. The sine of half pi is 1. Is that right? You give a sine function a number, and it gives you a number out. And that number loops because it's a wave, it's going up, it's going down. So you get a value from a sine wave of 1 to -1. And let's see, so I'm just going to do this in as simple a way as I can. I'm going to give it make a float up here, and then I'm going to plug that float into my sine. And I'm going to use this sine for my add. So I'm going to make a new vector 2. Oh, yeah, this will work. So I'm going to plug this sine into the X position of my UVs. And the Y is just going to be 0, so it's not going to add at all. Yeah. All right. So because I'm plugging a vector 2 into this add, it automatically just switched to using the first two values of that other vector. So they both say 2 now. If I go back in here, so now I have this sine value, and as I drag this up or down, it offsets the whole image left and right. So now it's going from 1 to -1, and then back to 1. Any questions about that? Does that kind of make sense? So it's just like, I'm just doing it to the whole image. So this is basically coming in, instead of like sliding it like I was myself, I'm putting it through this function that is offsetting it for me. So something else I can do is I can make a time node. So if I take my time and plug it into sine, then it's actually just going to do it by itself. So now I don't have to do anything. It's going to wave. It's going to wave back and forth on its own. And if I want it to wave faster, I can take time and multiply it by a number. I can add time. I can do all kinds of stuff with time at this point. So that's cool, but it's just like the whole image is just moving back and forth, which is not what I want. I want it to wave. So does anybody have an idea about how I might make a wave that is happening in space too, like in the image? So in this case, I'm taking a single value and getting the sine of that, but I can actually take, if I put something in that varies at every pixel, then I'm going to get an output that also varies at every pixel. Because this sine function is actually a program that's getting run at every fragment. So that sine calculation is being done at every fragment across the whole image. So what that means is if I give it an input that changes across the whole image, then that sine function will also give me something different for every one of those spots. So a very easy thing that we can give it that varies across the whole image are the UVs. The UVs go from 0 to 1, like across every pixel. Like no pixel is the same in UVs. Even ones that are very close to each other and look the same are all completely different because of linear interpolation. So if I want to offset my UVs, all I need to do is take my UV channel, and a sine function doesn't take vectors, it only takes floats. So I need to decide if I'm going to do the U channel or the V channel, and I'm going to have to split it out. So I'm going to split. So U is horizontal, V is vertical. So I'm going to take my, I'll start with V. We'll see what that looks like. So I'm taking the sine of that, and I'm going to go back to looking at my UVs so I can just see directly what I want to see as opposed to sampling the texture. Okay, so what we're seeing here is a skewing now. So what's happening is we are getting the sine of our V, and that's causing these UVs to be offset because I'm feeding that sine in. And the way sine works is that it repeats every 2 pi. So at 1, we're only seeing about 1/6 of a whole wave. So if I want to actually see a wave, I need to multiply that value. I think there might be a pi node. Oh, there's no pi. So 6.28 is roughly 2 pi. So if I plug that in there, then we should see a complete sine wave. So it's very extreme because it's going from -1 to 1, which is, the whole image is, tiling completely in one direction or the other. So what I'm going to want to do is like play with multiplying that down and adjusting the frequency. And then something else I can do right off the bat, so you can really see what's going on, is add time to that. So I'm splitting out that value, I'm multiplying it. Now I can add that value to time and plug that in. So we can see right in here already that we're getting an animated sine wave. All right, so it's going in the wrong direction. So if we want to flip that, got to take time, reverse it, stuff like that. So what we're looking at is the UVs, but with the alpha. So I'm going to unplug the alpha, so that's less confusing. Sorry, I wound up having 2 shader windows open, so it's confused. Save changes, yes, save, reload, okay. Okay, so this is just the UVs that we'll be using to offset the image now. So doing that, so I can plug the image back in. Okay, so this is just like a totally even wave. It's like going in the direction that I want it to, but I want it to wave, I want to reverse it, and then I want it to be more wavy on the top than the bottom. So I'm going to take my time. So actually, I'm going to change, so I don't need this anymore. So I'm going to change this to speed. And then I'm going to add another float called multiply. And then instead of giving it a magic number and just reversing time by some set amount, I'm just going to take time and multiply it by that speed value. Okay, so by changing that, I can go to the editor and set it to be -1 or -10 or whatever. And the next thing that I want to do is adjust the amount based on the Y value. So I want to multiply this. So I'm adding this sine wave to my UVs. So what I'm going to do is, I need to connect that to there. I'm going to make another multiply. So for this, I want to take that value. And I want to multiply that with that. And this is not gonna look right but I just want to show you what happens when I kind of do that directly. So what's going to happen is the bottom is going to be getting multiplied by 0, and at the top it's going to be getting multiplied by 1. So it's going to give us some slightly funny results to start. Actually, that's not as weird as I thought it was going to be. Cool. So yeah, you can see like on the bottom, it's not deforming at all. And on the top, it's deforming quite a lot. And then what I can do is multiply again. Is there any way to like have multiple inputs into a multiplier, or you just have to make multiple multipliers?
Weirdly, the effects graph will let you have multiple multipliers. I think shader graph won't let you do 2, but
Okay, so unfortunately you can't just multiply a whole bunch of things together in one node, so I do need to multiply all of this stuff. So I want to, before I multiply my sine wave by that value, I want to multiply it by my multiply floats that I'm getting from the editor. So now it's not doing anything because by default that value is set to 0. So it's just, so that's kind of like the amount that makes sense, you know, for a flame, just a little bit. And then one more thing. So another property of sine waves is frequency, which relates to pitch. So I can add another frequency float. And that's going to go. So instead of multiplying by 2 pi by default, I'm going to be able to multiply it by whatever I want. So if it is not very, very frequent, you can see the whole thing just kind of rocks back and forth. And if it's very frequent, we get a lot of waves. So we can adjust accordingly. So the flame is popping off the left and the right edge of the screen a little bit. So if I multiply that a little bit, should be able to crop it in. Of course, it's tiling. Let's see, do I still have that in there? Okay, I got rid of my adding. Let me put add back in. Okay, so now I can offset it, I can scale it, so I can make sure it's squeezed into the quad, so no matter how much it deforms. So this image is set to tile, so that's why it's tiling. So if I go back here and instead of having it repeat, I'm going to set this to clamp. And so now we just see one flame instead of a whole bunch of repeating flames. You can also do that right in the shader by clamping the UVs. So in order to clamp the UVs, you would just say, if you're multiplying it, there's a clamp node. So you can set it to say just like when it gets to 1, keep it at 1. If it goes below 0, keep it at 0. This is another way to do it. Okay. Any thoughts or requests for this flame?
Once I have that one little flame, can I easily make a bunch of them? Can I make a whole little fire from all over the place?
We can make so many flames. Yeah, so one thing you can do is once this shader is set up, you're not limited to these particular properties of this flame. What I'm going to do is duplicate the material. I don't need to duplicate the shader because I've exposed those parameters in the editor. By duplicating the material, I can give this next flame different properties. So if I drag this new material onto there, I can change its speed. I can make it more intense. So by duplication and variation, it almost, looks like a totally different image. And we can keep doing that and, create a bunch of these flames with a lot of variety.
Make a purple flame?
Purple flame, purple flame. Yeah, so you want me to do a hue shift? Is that a node in there?
I believe there's a hue shift node.
Okay, if we want to tweak the color. So hue shifts are slightly complicated mathematically. So if we make look at that, we got a hue. So we plug our output color into our hue, and then we plug that into there, and I'm going to make an extra float value called hue, and hue goes in here.
There's no like map to the function with the scale.
Oh, what's that?
For what?
For the distributed objects.
So you can either write the raw shader, but the shader graph may be a little bit slower. You can also do custom functions where if you just want to straight up write math, you can. But you show me kind of easy way where they do all the math for you. Purple.
Pretty. So just like everything else, like everything can be tied into time. So I'm taking this hue value and I'm plugging it in there, but I can also, let's say, create a time node, and maybe I'll multiply time by that. So we can have rainbow flames everywhere. Time, hue, multiply those, plug that in. So now if the hue is at 0, then you're just going to get the basic color. But if the hue is anything more than that, that's going to multiply by time and cycle through the full hue wheel. So it'll go red through every color and then back to red.
Did you get to billboarding on Tuesday?
And I talked about how it was a thing.
I just was curious.
Is there automatic billboarding in the shader
It
graph?
might actually be, but I disconnected it. But maybe there might be a billboard for it.
Speed Tree 8 billboard?
I don't want to distract you. I just that might only work for Speed Tree.
Yeah, so billboarding basically just means when there's a quad like this in the scene and you move around it, it will turn to face you, so that there's no way that you would ever wind up in a situation like this where you're just looking at the side of it. So you can do this on the CPU. There are ways to do it on the GPU. There's a function in C#, just called look at. So if you write a piece of code that says look at, it will just orient like that. Actually, this is a new thing that I don't use as much. It's not even that new anymore, but you can do an aim constraint. So if I choose these quads and I add an aim constraint, I can set the target to be the main camera. Yeah, so if I drag the main camera into my constraint, I can set these to be active, and then let's see, activate. There's some way to have this be active in the scene, right? Or do I have to be in play
It was
mode?
runtime only, but maybe I don't have the constraints only ran runtime.
Oh, I think. Oh, right. I just have to be
Yeah,
in.
might definitely one.
I just have to be in the game view. Okay, so I believe now if I take my main camera and move them around, so now they're always going to face the camera. So as I move the camera, those rotate. So there will never be a world where I can ever see the side of the flame. So that's super useful for things like, especially like this, because it's so animated and because it's symmetrical. Having it face the camera in VR or in games, whatever, that's a very typical technique. Anytime you see particle effects or smoke or whatever, it's going to be billboarding sprites.
It seems useful if you're making just like a scene that you're gonna shoot with a 360 camera. Like if you're gonna shoot around.
Yeah, so you can use it Dave for capturing like that, or even just real-time PDR.
Yeah.
So if David ran this in a VR headset, you could walk around this flame and you would never know that it was flat because it would always kind of look at you.
Right.
So there's a lot of directions that we can go from here. My plan was, and still is, unless we want to change directions, I was going to show you how to make water next, which is actually a little bit different, but pretty similar. I'm going to show you how to form vertices, so you can actually make waves that change the geometry. And then I was going to use similar tricks to make a volcano and have fire coming out of a volcano. But if anybody has a burning idea that is something you're working on, shout it out. Maybe we can throw it in there.
I like the fact that it's going to ghost.
Yeah, so David, just to show Roberta with this same effect, if you put like taking a sprite of a person or a little character, and then if you had this same effect, you could put this wave effect on like a figure or a person. And then also, you can do this stuff with the geometry too. You're doing this with UVs, right? It's all UVs.
Yeah, that's all you need.
But it's possible to have something that is a 3D object and also do this stuff to the physical geometry too. So David, Roberta's interested in doing effects like this on sort of figures, just make kind of like ghostly figures, either on 2D sprites or 3D models.
Yeah, if you have a 3D model, you can shoot that to me. Otherwise, I can drop in. So I just Googled person PNG. Let's see if it's really a PNG or a fake PNG. It's a fake PNG. Darn. How do you know? Is there any way to know?
I think Google, isn't it a advanced search of Google images to say that you want transparent?
There is, and you can also, I think, do file data.
But if you do PNG, you never know.
Yeah.
But I think if you do person and then do tools, I mean, things too.
It's one of those scams with the PNG.
True. Oh no, they don't. Oh wait, color transparent. It's under color, not type. Whether that's true, and they are transparent, who can say?
JFIF.
That seems to work actually. So David, it's under color, and that's good Google in the search tools.
Yeah, I found that. But all the images that are coming up are JFIFs.
Is it because of the browser? Are you just in Chrome or something weird?
It's just what those files are, but I think I got a PNG. Okay, so this one should work. So we can set a person on fire, duplicate this, and get that, and I'll drag in this new shader, new material. So I'm just going to drag in the person. Also set the person to clamp instead of repeat. And then same thing. So it'll work in the same way, basically, with any image. And there we go, dancing. This is what my Burning Man experience is going to be like in a couple weeks.
Is this what Burning Man is?
This is exactly what Burning Man is like.
Burning Man before we move out.
We're gonna put it in the fire in this part. That's a good dance, though. Burning Man. It's like, look at it. It like it's good.
How did you do that again? You just recorded in the view?
Yeah, I just so because it was a PNG with an already transparent background, and we set up the shader to work with transparency, I just duplicated the material and just dragged in a different image. So we can drag any image in there, and we can make anything wave however we want. The hue's changing, but it's sort of a black and white image, so you can't really tell. Okay, so I think for the water, I guess I should use noise for that. Yeah, I'll use noise. Should I show how to? I want to show offsetting an image with an image. Should I just do that with the fire? Should I do it with water? Something else? We'll do that with the fire. Okay, so this is a sine wave, but we are not limited to. I mean, there's lots of different ways to deform our UVs. One thing we can do is actually sample an image and then use that image to deform our UVs. So I'm going to make another version of this fire, but I'm going to use a texture to do the same kind of deformation. So I'm going to do a quick search for just, let's say, tiling noisy texture. Okay, so I just downloaded this. I haven't vetted it. It might, actually, this looks like it's not going to tile, but whatever. It'll be fine for now. So this is going to be it's going to be a different enough kind of shader that I don't just want this to be a mode or something. I'm going to duplicate this shader and set it up with an image instead. Okay, so I'm basically going to be able to get rid of pretty much all of this stuff, or at least some of this stuff. I'm going to add a new texture, and I'll call it texture. And I'm added an underscore there just because that's how script-based Unity shaders work by default, so I've just gotten used to doing things like that. So if I just take my noise texture and I just want to have a look at the texture first, just as a sanity check. I'm going to create a sampler. Sample texture 2D. Plug that into my texture, and I'm going to just plug that directly into the output. So I'm just skipping over pretty much everything else that I've built for now. So should I just start from scratch again?
It might be good to just see the process of going through it. You get a lot of notes here.
Okay. Let's just do that. I'm just going to delete everything.
Can you get the water now?
Hmm?
Is this water?
I'm going to do flames again, but using a
This
texture
displacement.
to do the displacement. So, all right. So noise texture going in there. So same thing again. I can right click on the shader and say create material. And then some slightly different spot. Okay, cool. So it's completely white because I haven't put anything into that noise texture slot yet. So I'm just going to drag that in there and we should see a nice noisy texture. So what I want to do is just sort of start again from scratch and use that to offset the UVs of the other object. All right, so this flame is still what I want to have be my output texture. So I'm going to plug that back in there. And then the alpha is also going to go in there. And what I'm going to want to do is affect the UVs that are going in there. So I'm going to start again and create a UV node. And I'm going to create an add. And I'm going to add, I'm going to try this. I think it might just work again directly. I might have to do some splitting of channels, but it might not. Let's see. I'm going to take my UVs and I'm going to add my output RGBA and I'm going to plug that into those UVs. Cool. So it did work. So you can actually see that noise texture coming through and affecting that. And it's actually pushing it way off the edge, basically. By adding it, the UVs are being offset. But by using that texture, they're being offset in a way that is not uniform across all of the UVs. So if I want to, let's say, make use of this pre-existing multiply, I can go in here and I can multiply. Texture before plugging that in. So now that multiply is 0, it's not doing anything, and I can basically adjust how much it's distorting my image like this. So this isn't super interesting yet because it's not animating. So I can do the same stuff as before with time. And what I want to do is take so I want to actually modify the UVs of my noise texture so that they're being offset in time. So I'm actually going to,
Is it tiling and offset another?
is there? Cool.
So you just sort of tiling on the offset, yeah, you can just image offset.
Oh, it uses UV by default? Amazing.
The default UVs are fine. If you leave that default, it'll just be normalized 0, 1 there.
So by default, it's moving very quickly. Speed. This is actually very useful. You can get all kinds of really cool effects from that. Kind of knowing how this works, you'll see this in lots of different kinds of real-time graphics. So we can do. I mean, if you're interested, we can dip into this, but we can do a lot of the same things we were doing with the sine wave, which is make it deform more on the top or the bottom. Right now, this deformation is happening in X and Y uniformly. So it's pushing it off the edge. Something that we'd want to do is, when it's getting multiplied like this, we also want to scoot it back in the other direction. So we'll do it like a multiply and like an add to move it over so that it's centered. So I don't know if you want me to get into all of that. If this is interesting, we could also move on to water or move on to the volcano. So do you have any opinions one way or the other? Should we dig in or water? What do you think?
It is super interesting to me, and maybe you can talk about just a little bit about like the role of noise in all of this stuff, because noise is huge. David had a research residency with the inventor of a very commonly used noise in computer graphics. But maybe just kind of play with that and talk about that in a minute, and then move on to water. Or unless you're going to use noise for water.
Yeah, I would use noise for water. So yeah, I think talk about it. That would be the moving on. So let's move on to water. Unless somebody has a question about this. Does this make sense? What I did here? I used an image with its own set of UVs to displace another set of UVs that I used for the flame image. So all good with that?
Can you go back to the branching and treat the and remove that?
Yep, so this is for animating the noise. So I take my speed, multiply it by time, and then that is going into this tiling and offset node. So this is kind of what I was doing before, but it's a better way to do it. So I just made my own X, Y, Z, W vector. This is basically the same thing, but they split it out so it's easier to deal with. But the idea is that tiling is the same as multiply, and offset is the same as add. And then it's taking this UVs by default, but you can put other things in there if you want. So I'm taking these sort of default UVs and just moving them. So this is just regular UVs. Like there's nothing weird happening with these UVs except that they're being moved. And then I use those moving UVs to sample my noise texture. And let's see, how do I set that? Default again. Yeah, I can set that up here.
So each characteristic has the vectors, I'm assuming, are the two dots. I mean, the number of dots that you can plug into.
So these can be lots of different things. So when it says 2, that would be a vector 2.
Right.
So UV is XY, so that's 2 values in one plug basically. So in this case,
add more.
so you can't add more to these. This is just like the way this node is programmed. It takes a certain number of inputs. You can make your own nodes, and your own nodes can have as many as you want, but typically you can pretty much do everything that you want to do without having to make any of your own nodes. So sometimes you'll have dots where they don't necessarily, like something doesn't have to get plugged into them, like they might be optional. But yeah, those are pretty much set, and like the inputs and the outputs will be set. So you can sometimes decide, which ones you want to use. There will be default inputs. So yeah. So this is the texture. It gets sampled by the sampler. The sampler takes a texture, samples it with UVs, and then so multiply is going to. So this is a multiplication of the texture. So that's basically taking the texture and making it brighter or darker. Let's see. Probably if I set a default value in here, Yeah, so if I change this default, you can just see it's like that texture gets brighter or darker, and that affects how much deformation gets passed along to the next set of UV coordinates. So the next set of UV coordinates is up here. So I'm just taking the UVs, adding that texture on top. So now this is what the UVs look like. So it's actually just the UVs with that texture on top. You can actually save out images of UVs too. You don't have to procedurally generate UVs. It is possible to go into Photoshop, make a UV image, and then sample an image like directly with that image. Not a very common thing to do. There are some drawbacks to doing that, but it's possible. So then we use this as the UVs to sample this texture, and then that goes out. So pretty simple. Something that I will do to make this kind of thing more fancy. So right now this texture is going in one direction. If I want to make something that's maybe not as directional, like let's say if I want to have clouds that are sort of changing and morphing, but not just like in one direction, I will actually sample that texture twice and then have them moving in different directions, and then either add them or multiply them on top of each other and use that. You can take the same texture and sample it with different amounts of repeats. So you can sample like a fine texture and then sample a broad texture, add those together, use that to deform the shader. So yeah, it's pretty powerful. Maybe I can find really quick an image of a tunnel of clouds I made recently for a project that made heavy use of this.
While David's looking, something to add to this, there's kind of two pieces of this that I think can be useful in a lot of other contexts. So one is, as David mentioned, the node-based editing, where you're sort of doing a lot of connecting the dots. That will be, you'll find that here in Unity in the shader editor, but also in other tools in Unity. And you'll also find it in a lot of other software. Like Dave mentioned, it's very common in audio software for like connecting kind of music input and output. It's common in, as David mentioned, in 3D modeling software like Maya, like Blender. But the thing to recognize is just underneath all of this, again, like David mentioned, is just code. It's just, so Roberta, if you remember in Yuri's workshop where we were doing the code to do sort of the distortion of the webcam, these are all the same ideas. It's just a different way of making them. And so there's a lot of different contexts where you will use shaders. There's a lot of different contexts where you will use these kind of node-based connect the dot tools.
I noticed on that graph, it gets so complex on the graph, when you graphed it out on the branches and all that. I mean, is there a concern about having too much of a web of?
Well, part of it is just, usually not so much for the computer, but for you, right, for a person to just organize it. So it's a little bit more advanced. If you get into something that's hundreds of nodes, and this is common in lots of software, you can kind of group a bunch of them together. And then as David was just explaining with those dots, sort of the inputs and outputs, you can make a web of 10 things that do a certain function. Say you have a complex thing to flip an image upside down or something like that. You can make what's called a subgraph. And so it basically just sort of encapsulates all that into one box, so you don't have to have 1,000 on your screen. It's a little more, normally you wouldn't do that unless you really start to get into a whole lot, but it is a way to sort of organize that. And most node-based software will have some way to do that if things get a little bit out of control.
Does it, in the same way, the more context, the more effect it has on the performance, or
It definitely can. I think David can talk about that some. There's certain things that you can do that the computer sort of good at, and it's kind of built to do, and it can just do it a billion times. And there's certain kinds of, even certain kind of mathematical operations, like doing a square root, for example, is a little bit harder for a computer to do than, for example, an addition or multiplication. And so that's a thing that over time, you become aware of, but sometimes you don't know until you try. So sometimes you kind of make something and then you realize, David does this all the time, I think, you can speak to this, it's like, you'll make something, you'll try it, and then you'll try it on the headset, or you'll try it on the phone, and it'll be too slow, and you'll go back and try it. So it's often an iterative process.
So maybe I'll repeat what you just said for the stream, if for posterity.
Oh, sure.
So yeah, Scott nailed it totally on the head. You can have very complex graphs and they can be very performant because there are things that shaders can do and GPUs can do very efficiently. Like if you're just adding and multiplying, you can kind of do that forever and just like have huge trees of things and it's okay. Things like sine functions or length functions or square roots, like if you're finding the distance of something, if you start to layer up like lots of sine waves, eventually there is going to start to be a performance hit. And then, yeah, like you don't necessarily know until you actually try it. So usually what I do is like, build things the way that I want them to look, test sometimes as I go, and then as a last step, like bring it back to, figuring out how to actually make it performant. And usually that means it doesn't look quite as good in the end to make it performant, but you've kind of figured out how you want it to look as you were going. So this is actually an example of a shader that almost worked really well in VR, but I did have to go back and do some of the math in the Vertex shader and pass some of that along to the Frag shader. So there are times when there is, if you're doing certain functions, and actually Scott and I were just talking about how our assumptions about this were maybe not right, because there's definitely some voodoo that goes into how some of this stuff works. But because there are so many fewer vertices, rule of thumb is if you do operations in the Vertex program and pass them to the Frag program, you're going to be doing a lot less math typically. So with this ring of clouds, for instance, I have a variety of sine waves. And by moving those sine wave calculations from the Fragment Shader to the Vertex shader and then passing them in to the Fragment Shader, I was able to get it to be much more performant. And then another issue with this, the way these clouds work is that I have basically a row of cylinders that are duplicated and scaled in different ways, and they're transparent and overlapping a little bit. So a big part of getting this scene to be performant was about having those cylinders overlapping just a little bit. If I had 3 cylinders overlapping, it got slow, but if I just had 2 cylinders overlapping, it was okay. So I had to just like carefully like tune and tweak and test, and it was annoying, but it took me like another half day, I would say, to take the shader from the way that I wanted it to look to being performant. And that's just, especially with mobile VR, it's something that you have to take into account as you're developing things. It's a good idea to optimize as you work, because if you make something that's beautiful and just the way that you want, and then you find out at the end you've gone way overboard with everything, then it's almost like you have to start from scratch. So if you know you're going to be building for a certain platform, you don't have to test every single step of the way, but have a plan and test as you go. That's pretty important. So yeah, these clouds are built basically the way that I just showed you. It actually only uses one texture, so it's like one noisy texture, and then all the gradients. And this isn't like a great representation of the scene. I didn't actually document like the fully finished scene, but it feels pretty satisfying, and it runs on mobile VR. And I got a lot of complexity just out of doing stuff in a shader with a single texture, essentially. And I took that one texture and I sampled it multiple times at different scales and different ways, and like offset the time to accomplish different things, and adjusted how I was clamping the image so it sort of fades in and out a little bit. And there's some like edging that happens here. So it looks a bit like it's being illuminated, but there's no lights or anything. This is all of the shading is happening completely in the shader. So yeah, so we have 30 more minutes, right?
Yeah.
Yeah.
Okay, cool. So I'm gonna hop in and make a little water shader with some noise.
Maybe we can keep going.
So I want to do a couple things here. And one of those things is I want to actually make the water create a wave on the vertices. So I'm going to offset the vertices of an object. And to do that, we need an object that has more vertices. Quads in Unity just have 4 vertices. Planes in Unity have 10 vertices. and they're just oriented a little bit differently. So a plane is 10 units, 10 vertices in each direction, quad just 4. That's not nearly enough for what I want to do, so I made my own plane in Maya and imported it. There's lots of ways to build geometry for Unity. Blender, Maya, there's a built-in tool with Unity called Pro Builder, and then Kajiro is an artist who makes tons of plugins for Unity, and you can do that. I have my own parametric modeling library that I snagged some code from Ken Perlin and brought it over to Unity, so I can sort of generate surfaces procedurally directly in Unity. There's no amazingly perfect way to do it. Pro Builder is probably a good bet for modeling stuff in Unity pretty easily.
Can you maybe just throw a quad in a plane and you're playing the scene with wireframe just to show people what that means in terms of it having more vertices?
So this is what a quad looks like. Geometry is built out of triangles. So even squares are triangles, circles are triangles, everything is made of triangles. So that's a quad. And then this is a plane. So a quad is 1 unit, which equals 1 meter in VR and AR space. So usually, for stand-in geometry, Unity primitives are usually pretty good, but I want to make some nice ripply water, so that's not quite enough. So I have a plane here that I call plane 100 by 100. It is, as the name suggests, 100 by 100. So a lot more vertices to play with there. All right, so I'm going to use a node in here. There's a few different kinds of noise. I think the gradient. So, and maybe I'll just pop them all up so we can look at them. So there's gradient noise, simple noise, sometimes this is called cell noise in other programs, but the idea here is that it's basically balls that expand outwards, and where the balls sort of touch each other, you get these hard edges. Voronoi is a technique that's used in combination with another trick called Delaunay triangulation, which can give you meshes from point clouds. But in this case, it's just being used in a shader directly. So these are a few examples. The performance of each of these is going to be different, and right now I don't know necessarily which one is the most performant. My guess would be that this is the most performant, and this is the next most performant, and this would be the least performant, I think, but I would have to look into that to be able to guarantee that. So the way that, so Perlin noise has been around since the very early days of computer graphics, and it was built in order to solve a problem in the early days of computer graphics, which was that blocks of memory were very expensive. So actually using textures just actually cost a lot of money. Having one 512 by 512 texture was another $5,000. So each texture just literally cost a lot. So in order to be able to create a lot of interesting variety in textures, there was a need for algorithms that could generate these textures procedurally. So the nice thing about this texture is that it's all happening in a shader. The computer is doing all the work, the shader is doing all the work. There's no need to have a texture that lives anywhere. The files are basically don't have any size, so you can do lots and lots of stuff with noise, and it doesn't take up any room. There's an animation studio that is no longer called Blue Sky Studios, and at least in the early days, like for Robots, their film, they did everything procedurally. So if you want to load up that movie and look at it, you can see how intense you can get with like really digging into using noisy textures to do lots of very complex things, because you can take noise and you can multiply noise with noise. You can have different frequencies of noise do different things. If you grab the absolute value of noise, you get sort of different qualities from there. So there's a huge amount of variety you can actually get from noise. So it doesn't look that interesting, just like this, but by combining things in different ways, you can actually do really cool things with it. So I'm going to use gradient noise to do some stuff. It looks nice. Just look at it on our plane at first. So I'm just going to go out directly into the base color. Okay, so that's like pretty much one-to-one, noise on noise. Noise is, similar to other kinds of complex mathematical operations. So a nice thing about noise is it's free in terms of textures, but it does have, can somebody close the door? It's a little loud out there. So it is, oh, I guess they're not done yet. So it's free in terms of texture memory and that kind of stuff. You can have a lot of, noises in a scene, but it can get expensive in terms of processing power, especially if you're layering lots of noises on top of each other. Once you get to where you have 4 or 5 different noises being sampled, it can slow things down. So you do have to be a little careful of that. But another nice thing about noise is that it is infinitely detailed. So there are no pixels in here. However close you get to it, you're just always going to have a perfectly smooth gradient. And just under the hood, the way it works is there's basically a grid of points that are at 0. So if you can imagine a line, that line is divided evenly. So 0, 1, 2, 3, there's a point. Each one of those points basically gets a direction, and that direction is random and seeded. That's why it's randomized, but it's always the same each time. So if you know Illustrator at all, it basically uses splines in a similar way. So basically each point gets a direction, and then there's a line that would get interpolated sort of through those randomized directions. So if anybody's interested, I can tell you a little bit more about it. I have not written my own noise from scratch, but that's basically how it works. So we can use this to make some water. So I'm going to do the same thing and use a noise to offset another noise to make this ripply. So let's see. So noise is sampling from the UVs. Noise can actually sample from anything that you give it. I mean, the same way we can sample images from anything. We can sample noise from the world position. We can sample noise from normals, kind of whatever we want. But in this case, UVs are easy. So I'm going to take this UV, plug it into that UV, and I'm going to make an add. And I'm going to add this noise to these UVs. Oops. And then use that as the UVs for that noise. So it's already a little bit more water-like. And then I can start playing around with time again here. So in the same way, I can add So I just made a vector 2 that's going to be exposed in the editor, and I'm going to use that as the displacement here. So if I go into my editor, so I'm gonna work on making different kinds of ripples. Offsetting quite a bit, so I'm going to multiply that down a little bit. Yeah, so something in there is maybe a little bit more normal. And then I want to do time, of course. So I have distort speed, but I'm going to multiply time. So this is the thing I don't love about node editors is they can get very complicated pretty quickly, and you always have to be moving around nodes. So you can group nodes in here. There's no automatic layout stuff, but it's very easy to wind up with tangled webs of things that are on top of each other. So it is good to organize as you go. Okay. And then I also, so right now I'm offsetting distortion. So I'm going to go ahead and also change the amount, the level of detail for this. So I also want to have a multiplier in there. So that would go all the way back here into the UVs of this first noise. So I'm going to make another UV. Oh, no, actually, sorry, the repeats are actually built right into the gradient noise. So I can plug that directly in there. So I can keep going with this. I can like add another layer on top of that and distort the noise that's distorting the other noise. I'm just going to do one more thing, and that is I'm going to add time. Let's see, which one do I want to add it to? I'm adding time up there, so I'm going to add time to this UV set as well. Let's do simple things. I need to add, not multiply. To do what? To get them to tile?
Yeah.
So with noise specifically, or you mean textures in general? So noise never tiles. That's a really cool thing about it. So it's always seamless and it never repeats. It's always very similar to itself. But that's like actually a really useful thing about noise is that it actually like never repeats basically. So with textures, there's like a trick I can show you maybe in the afternoon. It's like you can go into Photoshop and like tile it and then offset by half and like paint out the seams. That's basically the way to do it. Okay, so this is, this is a pass at water. It's not like the most amazing water in the world. But we can, and I can keep going with that, but I want to switch to using this to distort vertices. So that's a little more interesting for now. Actually, I guess one thing I should do is I'm just going to add a color and multiply that by the color at the end. So it actually looks like water. So take that, multiply by that, and set the default color. Okay. So in order to deform vertices, it's basically the same stuff. It's math in vertices is not different than math for pixels, but we do need to sample something a bit different. So I'm going to make a let's see, position. Take this position node, and I'm going to put it in object space. I'm just going to show you the color of this really quick first. Okay, so this is kind of similar to UVs in some ways. These colors represent the position of the vertices. So everything is black over here because these are negative. So this is 0, this is the center of the object. So as it gets bigger in X, it becomes more red. As it becomes bigger in Z, it becomes more blue. There's no green because there's nothing up right now because this is just a flat object. No matter how I rotate or scale the object, those values don't change. So I'm going to switch this to world real quick and save that. And now it changes a bit. So what's happening here is that this is based on units now. So if we look at the units, it's 0, 0, 0, and X, Y, Z at 0. But then as we go 1 unit over, it becomes red. And as we go 1 unit back, it becomes blue. So at 1, 0, 1, and 1, 0, 1, because Y is 0, it's purple. And then everything up here, it looks like flat purple, but it's actually purplier than purple because it's going up in value. So this isn't just red. This is the opposite of infrared.
Sorry?
What's the opposite of infrared? What's super?
Ultraviolet?
Ultraviolet. So this is infrared down here where we can't see it. You need a telescope for that. So if I rotate it now green comes into play because that's in Y. So this is representing this object's intersection with its position in world space. So what I can do is use that to sample various things and then use that to actually change the position of vertices. So just to keep things predictable, I'm going to be in object space. And then what I want to do, so I'm just going to see what happens real quick if I plug that into position, because my hope is that that will just work fine and not do anything weird. Oh, what am I doing wrong? Position, object. Okay, there we go. I guess it didn't like to be plugged into both. What? That's weird. I can't plug into both at the same time from one node. Okay. Okay, so that position, if I plug object position directly into position, it's going to be the same. So I'm not doing anything. That's just A to B. I'm taking the position of the vertices and I'm giving that position to my output. But what I want to do is deform this in the same way that we were deforming things before. And I think I'll go ahead and start with a sine wave. So instead of taking a U or a V, I'm going to take a X or a Z value. So I need to split out one channel from this world position. I'll take red, and then same way I did before, I'm going to multiply that by a value. Oops, I did that the wrong way. I actually want to do that before. So I'm going to take my X value, I'm going to multiply that, and then feed that into my sine. Okay, so we have a lot of ripples. Again, it's like it looks black, but really it's less than black. So that will give us negative values. And then if I take this sine wave and add it to this position, we should be able to make waves. Now it's going to be a bit weird because it's going to add to every channel. So instead of going up, it's actually going to go at an angle because it's going to add to X, Y, and Z. But let's have a look at that. Okay, cool. Wow. So it's doing it by a lot. So even though I have 100 by 100 vertices, my object is actually pretty small. So when that sine wave moves it up by 1, it's moving it up by quite a lot in comparison. So I'm going to multiply this by a bit less. So just a few waves instead. And then I'm going to, so this is just a vector thing. If you multiply a vector by a scalar, if you multiply 3 values by 1, it's going to take all 3 of those values and multiply each one of those by that float. And I want to do that just to one channel. So I'm going to create a vector 3. And I'm going to plug in this output. So it's black and white. So that just means like it's either a vector 3 with all the values being the same, or it's just a float value. So I'm going to plug that into my y-axis. And that's what I'm going to add. So I'm adding 0 to x and 0 to z, and that value to y. And then before I do that, I want to do a multiply, so it's a little bit smaller. It's a very tiny number there, but now it's 0.12 instead of 1. So now I want to save the assets. So now I have a nice wave instead of something that's quite as crazy. And now it's just moving up in one instead of over in a strange direction. And then I can do all the same stuff that I was doing before with time. So what I want to do is, I'm splitting it, I'm multiplying it, and somewhere in there, I want to do an add. Maybe after my multiply, I'll do an add before the sign. I'm going to add time to that. Cool. So now I have a moving wave. I'm just going to make it a little more frequent. That would make it a little smaller. Okay, now I certainly do not have to use that as the color channel, so I can actually go pop back into my water and plug my water, it's so small, into my color. So now I have the watery texture with the wavy deformation, and there's certainly no reason that I can't take that noise and also use it to offset the vertices. I can do things like use, let's say, texture maps to affect how big the waves are. So if I had an object where I didn't want the waves to be affecting it, I can make them smaller. I can have the waves move out from a central ripple. There's just like a huge amount of variety we can get out of this. One thing I'll try real quick, since we have 1 minute till the break, I'm gonna be right on time. I think I can take the output of this, and if I put it in the right spot, I can use this deformation to affect my noise as well. So if I take this stuff in here, and where I put it will change what effect it has. I'm just going to make a guess right now and just like put it somewhere where it seems like it might be good. Slightly random choice. I'm going to go from here and I'm going to add that and then plug it in there. So I'm going to take that and I'm going to add it to that, and I'm going to put that into there, and it might be a little crazy. Yeah, so that's a bit much, but I can tone that down a bit. So now the noise is being deformed by that same value that is causing the ripples to happen. So this is a huge rabbit hole when you start playing with stuff like this, because everything can get plugged into everything else, and you can have like tons of variables affecting this stuff, and it's pretty powerful.
So if you like the effect that you created, and you just save the file and it will save the map with what you just did?
Yeah, so there's two aspects to that. One is the shader. So as you're working and you save the shader is just there. The other part of that is the material. So usually what you'll do is expose a lot of parameters up here. So there's kind of two parts. Like to get a material that's doing what you want, there's the shader, which is a program which has numbers that are meant to never change built into it, but then you feed it variables from outside, and that stuff gets saved in the material. That's the thing that actually gets applied to your object.
So as a programmer, then, I'm thinking comparably to a recipe. So do you write down your recipes in that respect?
So you can do stuff like, the material is the recipe, and the fact that it's saved right there means like that's where it is. So as long as you don't delete that material, then you're okay. I think you can go up here into your material, and I think you can save your material to a preset. So if I just go up here, I can say, I like this water, and then add the preset. And then if you want to make a new material later, you can load that preset up. So thanks for people who are watching the stream. That's it. Lunchtime. Thanks.
Thanks, David.
Thank you.